So this is assignment alcohols and halogen alkanes. First 13 questions already recorded, so I will start with question 14 onwards. So in this question is about two halogen alkanes. One is X, another one is Y. So can you identify what is X, like primary, secondary, or tertiary? Carbon attached to halogen alkane. A carbon attached to halogen is surrounded by or having one carbon chain. The carbon which is attached to halogen is having only one carbon chain. So which one is this? So it will be primary. And here a carbon attached to halogen is surrounded by three carbon chains. So this is a tertiary. Draw the skeletal formula of X. So we have to draw the skeletal formula of X. First, how many carbon are there? There are 4 carbon atoms. So we have to draw the 4 carbon atoms. The skeletal formula which shows the carbon chain and the function group. So 1, 2, 3, 4 carbon, and then there is a Br. So then there is Br. So this is skeletal formula, or you can start with 1, 2, 3, 4, and then Br. Then we have to name Y. How to name this? First thing, we select the longest carbon chain. So 1, 2, 3, 1, 2, 3. So maximum 3 are there. So we can select any, like I can select vertical like this, or I can start from the left hand side like this. So it won't make difference, as we will have the second position, the iodine, and the methyl group is attached. So second position we have iodine, and second position we have methyl. So it is 2 iodo, 2 methyl, and then 3 carbons of propane. Or it can be, you can name, normally when we name the branches, we named according, like in alphabetical order, but it is acceptable if you write 2 methyl, 2 iodopropane. So this one is 2 iodo, 2 methyl, and then, but remember, whenever branch is there with, in propane, whenever there's a branch, so only one possibility, it's obvious that it should be with the second carbon. So whenever the main chain is propane, we don't have to specifically mention the position. Like if I say 2 iodo methyl propane, so this is obvious. Why it is obvious? Because it is obvious that the carbon, the chain which is attached as a branch will be, or it is with the second carbon. So if I don't write 2 here, this is also correct. Then the next one, write equation for reaction of X with alcoholic solution of ammonia and name the organic product. So now remember, with ammonia, alcoholic solution of ammonia, it's a substitution reaction and it results in a formation of amine. So first we have to write. So first one is bromobutane is there, C4H9Br, because we need the equation. So C4H9Br plus ammonia is there, which is NH3. And just to explain the idea, in NH3, NH2 is partial negative and H is partial positive. And here, bromine, which is more electronegative, is partial negative and carbon chain is partial positive. So a substitution reaction will occur, means this NH2 will take position of Br and the Br will take position of NH2. So this will result in the final product will be C4H9NH2 plus HBr will be there. So this will be the final product. But as I mentioned, this reaction normally, the HBr, this is correct. Like this is, but normally what happened, uh, if you use excess, so instead of hydrogen bromide, because this hydrogen bromide can react with, hydrogen bromide is acidic. So it can react with another molecule of ammonia, and this might result in a formation of ammonium bromide. So this hydrogen bromide, HBr, react with another molecule of ammonia. As we use excess of ammonia for this reaction, this will produce NH4Br, ammonium bromide. So if I have two molecules of ammonia, then the final product, if I write for because one molecule is reacting with halogen alkane and the other molecule is reacting with the product hydrogen bromide to give ammonium bromide. So if I just write a complete equation for this, I can say C4H9Br plus two molecules of ammonia. Why two? One molecule to react with halogen alkane, another molecule to react with the product hydrogen bromide. So this will result in a formation of C4H9NH2 plus NH4Br. And name the product. So what is the product of this reaction? So it is four carbon atoms, so it is butyl, and NH2 group is there, so amine. So it is butyl amine. Is it clear, this one? So you can write with the one molecule, even because as they did not mention here that we have an excess of ammonia or a limited supply. So you can write the equation for both of them. Either you can write for one molecule of ammonia and produce hydrogen bromide, or two molecules of ammonia produce ammonium bromide. Both are acceptable. As in the question, it's not mentioned whether we have access or a limited supply of ammonia. The next one, when Y is heated in aqueous solution of potassium hydroxide. So remember, whenever you have aqueous solution, it means substitution reaction will occur. And alcohol is formed in two steps. Write the mechanism of this reaction using curly arrows. So this is a tertiary halogen alkane. If a tertiary halogen alkane and it undergoes a substitution reaction, it will be SN1 reaction. First the bond will break, then the bond will form. But if this was a halogen alkane and it undergoes substitution, then it should be SN2, in which the bond breaking and bond forming will take place at the same time. So we have to complete for 2-iodo-methyl propane, the substitution reaction. As you can see, this is highlighted aqueous. So what does it mean? It means it should undergo a substitution reaction. So the reaction mechanism, first, we have to draw the curly arrows to represent the structures, like the distribution. So first we have a halogen alkane, tertiary halogen alkane. Then, because here the bond should break, so both of these electrons are taken by this iodine. So the intermediate will form a carbon cation, and this carbon cation will be more stable because this carbon cation is surrounded by more alkyl group, C alkyl group. That's why it's more stable. Then we have, like, this is first thing, plus iodide ion. And then what happened? This halogen alkane, there will be attacking nucleophile, OH will be there, that will attack on the carbon, and that will result in a formation of 2-methyl propanetol or methyl propanetol. So this is actually the reaction mechanism for, so arrows from iodine to arrows within carbon and iodine bond, that will give you 1 mark. Correct structure of a carbon cation give you another mark. Then arrow from OH to, because arrows are always, we draw from the electron rich side to electron deficient side. Is it clear, this mechanism for substitution? The next one, when Y is heated and when Y is heated with an alcoholic solution of potassium hydroxide, alkene is formed. What type of reaction? So this we call elimination. Separate ethanolic solution X and Y were warmed with water containing silver nitrate. Describe what we'll see in each case. Ignore any difference in the rate. So we don't have to. One is containing a bromide. X contain a bromide ion, so it will form silver bromide. What will the observation? Will observe a cream PPT. But Y contain iodide ion. So what is the observation? The observation will be white precipitate or white PPT will be there. Sorry, iodide ion. So yellow PPT. White PPT is for chloride ion. So this will be yellow PPT. Then the rate of hydrolysis of a primary halogen alkane are affected by strength of the bond between the carbon and the halogen. In CBr bond weaker or stronger, is the CBr bond weaker or stronger than CI? Explain why bond strength are different. So what is the reason why the bond strength are different? Like CBr will be stronger. 1 mark when you mentioned the bond strength of CBr will be stronger than the bond strength of CI. The reason is that CBr is because bromine is smaller in size, so bond will be shorter, the nuclei will be closer. So answer here, first we'll mention the carbon bromine bond will be stronger than carbon and iodine bond. And what is the reason for that? Because the bromine is smaller in size, so the nuclei will be closer. For CBr, as a result, they will have a more attraction or stronger attraction, result in strong bond. But iodine, as I mentioned, it is larger in size, so the bond will be weaker.